Each problem I go through, I'm going to do it very quickly. You could pause and take notes as we go. If we have the area under the curve, okay, the mean would go here, as we know from prior things, and the area under the curve is 1. So if we start here at 0, we end here at 1, or we start here at 0, we end here at 100% if we're doing percentage, okay? All right? So if we have some value C, okay, greater than means higher than, okay? So if the probability of some Z value greater than C is 0.26, okay, then the probability of that same number that's negative, the probability less than that same number is also 0.26. Okay? All right, so the answer is true, okay? If the probability of some number greater than C is 0.1, okay, then the probability here is also 0.1, which means the probability in between is 0.8 because it has to equal 1 all the way across from beginning to end, right? So if this is 0.1 and that's 0.1, then the probability in the middle between negative C and C is 0.8, which is true. First, remember, the probability of anything less than the mean is 0.5, and the probability of anything greater than the mean is also 0.5, okay? All right, the mean is right in the middle, okay? Probability of randomly picking a score or some type of data point less than the mean is 0.5 and greater than the mean is 0.5 is right down the middle. So if x is 7.2 and that's 0.48, which means I'm going to draw that right here, some x value, which is 7.2, and this is 0.48, right? Then the greater than, the other side of it, must be 1 minus that, or 0.52, which is a true statement. And this one, we have a mean of 3, okay? And so greater than 4.9. So 4.9 is greater than 3, so I'm going to put it on this side of 3, correct? And if that probability is 0.38, and remember what I said just a few minutes ago, 0.5 from here to here, right? You know, starting in the middle. That means this probability must be 0.12 because it has to equal 0.5. Greater than 3 has to equal 0.5, and the total greater than 3. So if greater than 4.9 is 0.38, then yes, the between 3 and 4.9 is 0.12. And again, I'm going to put A on the right side of the mean. Okay, we don't know what the mean is, we don't care. But I want to always put it on the correct side of the mean, all these problems. So 0.66, because it's higher than 0.5, goes on the right side of the mean. That means anything greater than A is 0.34, correct? So if I do negative A over here, that must be also 0.34. All right? Because basically I'm using the fact that 0.34 is higher than A, which means 0.34 is also less than negative A. In a normal distribution, if the mean is 10, then the median is also 10. But that's just in a normal distribution. You do not need Excel to calculate a z-score. The z-score is simply the x value that they're asking for. Remember, x is always a data point, minus the mean, divided by the standard deviation. X minus the mean divided by the standard deviation. The data point in question is 27, minus the mean 24, which is 3, divided by the standard deviation, which is 2, to give us 1.5. Remember, the z, what does z mean? When we say the z-score, what does that mean? The z represents how many standard deviations a certain data point is away from the mean, either below or higher than the mean, okay? So if I'm 1 standard deviation below the mean, the z-score is -1, okay? Because any score that's below the mean has a z-score that's negative. Any data point that is higher than the mean has a z-score of a positive. Look at the formula. Positive, if it's higher than the mean, you're going to get a positive in the numerator. If it's lower than the mean, you're going to get a negative in the numerator. X meaning the point in question. Okay, and then if it's 2.3 standard deviations above the mean, then the z-score is 2.3, positive. Okay, and again, the z-score at the mean itself is 0. The mean is 0 standard deviations away from the mean. It's right at the mean, so the z is 0. So in other words, if I'm going to pull up go back to our thing. Here's the mean. The z is 0. Okay. Here's 1 standard deviation higher than the mean, 2 standard deviations higher, 3 standard deviations. These are the percentages. 1 standard deviation lower, 2 standard deviations lower, 3 standard deviations lower. Okay. Those percentages are not correct. No, forget those. I just noticed that these percentages are not right. It's in my video, you'll see the correct percentages. I didn't bother doing the first two because it's just using the standard formula I just showed you. However, what value of x has a z-score of 1.29? Okay, so at what point is the score 1.29 standard deviations higher than the mean? You use this formula right here. Okay, you just algebraically manipulate this formula to get this. Trust me, if you do the algebra, this is what you get. So the mean is 20 plus 1.29, the z, times 7, you get 29.03. When you do this problem, it doesn't even matter what the actual scores are. You do the z for each. You do the z-score for Natalie and the z-score for Crystal. Regardless of the test grade itself, the answer is who has the higher z-score. The higher z-score did relatively better than the rest of their classmates, okay? So they're not asking you who did better, because that would be easy. You just say, what's Natalie's grade? What's Crystal's grade? We're not asking who scored a higher grade. That's too easy. They're saying, relative to the rest of the class, who scored better? And that is just determined by which z-score is higher. Now, they're both negative. So negative 0.03 is higher than negative 0.42. So just whatever's bigger, whatever z is bigger. So Crystal did relatively better because her z-score was higher than Natalie's. Okay, these two are easy. You just plug in the mean here, the standard deviation here given. So everybody should get part A right. Less than 2761. Remember, Excel works left to right or less than. Okay, so if I'm given, okay, the two formulas, two key formulas I'm going to use when given, actually I'm going to type it out because I can do it quicker. Oh, actually I did it for class earlier, okay. I'm going to get to this later, but I'm going to type it in. When given probability, or given x value, find the probability, use norm.dist in Excel. When given probability, and this can be a percentage too, probability percentage, same thing, find x value, use norm.inv in Excel. Okay. The only trick is you have to manipulate. Excel works left to right or less than. You have to know that when you're inputting values. But other than that, okay, all right. So when we get to a problem using norm.inv, I'm going to go over these things here. Okay, all right. So in Excel, I'm given the x value, less than 2761. Find the probability, so I'm using norm.dist. Okay, formulas, more functions, statistical, norm.dist. The x value is 2761 as given. The mean is above 2879. Standard deviation is 540. Cumulative is always 1. I don't know of any point in this chapter that it's never anything but 1, okay? All right, so there's the probability less than. And so that is my answer. Because why? Because they asked for less than, okay? However, in the next part, they're asking for greater than, okay? You're going to find the less than. Remember, Excel always does less than. It doesn't calculate greater than for you. You just have to know when you're calculating greater than, you get your answer and subtract it from 1, right? So we do the same thing for part C, okay? Formulas, more functions, statistical, norm.inv. We're going to get a probability, remember probability, no, I'm sorry, norm.dist, I don't know what I'm thinking. Formulas, more functions, statistical, norm.dist, sorry about that. Just was jumping ahead to the next one. Norm.dist again, so this time it's 3213. Here's your x value, okay? 3213. Your mean is still the same, 2879. Standard deviation is 540. Cumulative is 1. Okay. All right. That is not your answer, though, because that calculated less than. Excel, I'm going to repeat. Excel always calculates less than. Excel always calculates less than. If they ask for less than, you're fine. You find less than, it's over. If they ask for greater than, you have to subtract it from 1, because remember our little curve, okay? Here is the greater than, okay? What is that? What are we asking? So if I find this, because the entire area is a curve, so if I find this probability, then this probability, so P2 equals 1 minus P, okay? Because you're looking for greater than. Excel always calculates less than. Repeat after me. Excel always calculates less than. That's where most students miss these problems, okay? Excel is not going to calculate greater than. It's going to calculate less than. So you have to know that. Once you get your answer, you do 1 minus, you can do this on your calculator. Just go ahead to 4 decimal places, 0.7319, 319, and 1 minus 0.7319 is 0.2681, okay? 0.2681, all right? %, who consume the most calories. Now they're giving us a probability. Find the x value. What is that x value? Okay, so here's what they're asking. Okay, here's what they're asking in this one. Okay. Okay, what is that x value? Okay, how many calories do I have to consume to say that I just consumed more than 98% of the people that were surveyed, okay? So you do not you use norm.inv because they're given a probability, find the x value. So you do not put in 0.02, you put in 0.98 because remember, Excel always works left to right. Excel always works less than. So you have to know that in this case. If they're asking the top 2% in this case, okay, you have to put 0.98 because that's how Excel works for you. Okay, you just have to know that. I don't know how else, you're just going to have to pay attention and be smart. Okay, so this time I'm going to use formulas, more functions, statistical, norm.inv. Okay, probability 0.98, not 0.02, 0.98. Mean is 2879. Standard deviation is 540. There's my answer, 3988 calories. So what it's saying is, if I consumed 3988 calories, I would have consumed more than 98% of the people in this survey, okay? Only 2% of the people in this survey consumed more than 3988 calories, okay? All right? When I do tweeners, in-betweeners, I call them tweeners, okay, put the mean here at 22, 25, 28, in between. I'm going to do less than twice, Okay, I'm going to do less than 25.